Everybody, let's try this distributed load problem. So let's start with the free body diagram. So there's a bar. I'm going to pick coordinates like this. Okay, there's a pin at A. I'm going to decompose that reaction into X and Y components. There's a roller at B over here, normal to the surface. And then there's a distributed load that looks like a composite of a rectangle, a triangle, and then another triangle over here. Okay, and the strategy is that we can replace the distributed loads by discrete forces, where the magnitude of those forces are the areas of those loads, so of the shapes. So for example, the rectangle, what is the area of the rectangle? 2 times 4, so 8 kilonewtons. Okay, what's the area of this triangle? 1/2 base times height. So, okay, so here to here is 3, here to here is 2, so this has got to be 1. So 1 times 4 divided by 2, so 2 kilonewtons for this triangle. And then for this triangle, the area of this shape, 1/2 base times height, 3. And the location of these loads are at the centroid. So for the rectangle here, for this triangle here, for this triangle here. So for the rectangle, halfway, so that's 2 meters. For this triangle, here to here is 2/3 of 4. 2/3 of 4. So 8/3. Okay, and then for this triangle, here to here is 2/3 of 2. So here to here is 4/3. Okay, I think, so we got all the geometry set. So now let's write Newton's laws. Okay, x direction, ax. That's all. Okay, y direction, ay, by, and then these 3. -8, -2, -3. Alright, now let's sum torque about wherever we feel like. You can sum torque about A, about B, about the end over here, about the middle. There's no wrong choice. So it's best to choose somewhere with a lot of forces intersecting that point. So like right here is a good choice. So sum torque about point A. So the torque by this one is going counterclockwise, which is in the positive z direction based on how I pick my coordinates. So that will be positive. So that's 4 meters times B. Okay, and now the torque by this one is going this way, negative. 2 meters times 8 kilonewtons. This one, negative. 8/3 times 2 kilonewtons. And then this one is, how far is that? That's actually, here to here is 4/3. Here to here is 6. So here to here is 6 minus 4/3. Okay, 6 minus 4/3 is like 18 over 3 minus, so 14 over 3. Okay. So all that equals 0. So now we have 3 equations, 3 unknowns. So solve that, ax equals 0. I'll solve this next for b. So b is, let's see, that's 16 plus 16 over 3 plus 14 over 4. Okay, so that's, let's see this. That's 30, that's 5 1/3, so 35 1/3 divided by 4. I punch that in the calculator. 8.883 kilonewtons. Okay, and then we take that number, plug it right here. So then AY is, how much is that? That's 13. 13 minus BY. So 13 minus 8.83 is 4.17. Okay, so we got BY, AY, AX. Okay, hope that was helpful. Keep on practicing these distributed load problems, and I'll see you on the next video.